Minotaur IV. Minotaur IV, also known as Peacekeeper Space Launch Vehicle, SLV, and Orbital Suborbital Program 2 Peacekeeper, OSP-2 PK, is an active expendable launch system, or expendable launch vehicle, ELV, derived from the retired LGM-118 Peacekeeper Intercontinental Ballistic Missile, ICBM. It is operated by Northrop Grumman Space Systems, and made its maiden flight on April 22, 2010 carrying the Hypersonic Technology Vehicle 2A, HTV-2A. The first orbital launch occurred on September 26, 2010 with the Space-Based Space Surveillance, SBSS, system satellite for the United States Air Force, USAF. The Minotaur IV vehicle consists of 4 stages and is capable of placing 1,591 kilograms, 3,508 pounds, of payload into a low Earth orbit, LEO. The first 3 stages are decommissioned Peacekeeper missile motors. On the baseline Minotaur IV, the 4th stage is an Orion 38. The higher performance Minotaur IV Plus variant instead replaces the Orion motor with a Star 48BV 4th stage. A 3-stage configuration, no Orion 38 or Star 48, designated the Minotaur IV Lite, is available for suborbital trajectories. A 5-stage derivative, the Minotaur V, made its maiden flight on September 7, 2013. Minotaur IV launches are conducted from Space Launch Complex 8, SLC-8, at Vandenberg Space Force Base, VSFB, Launch Pad 0B, LP-0B. At the Mid-Atlantic Regional Spaceport, Mars, Space Launch Complex 46, SLC-46, at Cape Canaveral Space Force Station, CCSFS, and Launch Pad 1, LP-1, of the Pacific Spaceport Complex, Alaska, PSCA. The Minotaur IV was developed by Orbital Sciences Corporation, commonly referred to as Orbital, now owned by Northrop Grumman Corporation, as part of the United States Air Force's Orbital Suborbital Program. There are 3 variants available, Minotaur IV, 4 Plus, and 4 Lite. Minotaur IV and 4 Plus are used for low Earth orbit missions, while Minotaur IV Lite is intended for suborbital launches, such as testing prototype hypersonic vehicles. The separate Minotaur V and Minotaur VI rocket variants are also available, with the former optimized for high-energy trajectories such as geostationary transfer orbit, GTO, or translunar injection, TLI, and the latter intended for heavier low Earth orbit missions. The Minotaur IV family is derived from the LGM-118 Peacekeeper Intercontinental Ballistic Missile, deployed from 1985 until 2005. The Minotaur IV family utilizes decommissioned LGM-118 Peacekeeper solid rocket motors, which compose the first 3 stages in all Minotaur IV rockets and derivatives. This relatively simple architecture allows Minotaur to be launched from essentially anywhere in the United States through the use of mobile launch facilities, although this capability has never been needed. Because of its use of decommissioned ICBM components, Minotaur IV can only be used to launch U.S. government missions. The standard Minotaur IV rocket is composed of 4 stages. The first stage SR-118 motor provides 2,224 kilonewtons, 500,000 pounds force, of thrust during its 56.6-second burn, followed immediately after by stage separation and second stage ignition. The second stage, powered by an SR-119 motor, burns for 61 seconds and provides an average thrust of 1,223 kilonewtons, 275,000 pounds force. The third stage then burns for 72 seconds, with an average thrust of 289 kilonewtons, 65,000 pounds force. The initial 3 stages all have thrust vector control, TVC, allowing them to steer the rocket downrange by gimbaling the motor nozzles. The second and third stages also feature extendable nozzles, allowing for improved performance in the upper portions of Earth's atmosphere as well as the vacuum of space. The 4th stage of the Minotaur IV is the Orion 38 motor, which is also used in the Minotaur C, Minotaur I, Pegasus, and Ground-Based Interceptor, GBI, rockets. This motor performs the final orbital insertion burn for the payload. Like the first 3 stages, the Orion 38 also features thrust vectoring, with a 5-degree range of motion. The first 3 stages make up the majority of the rocket's body, while the smaller fourth stage is housed in a hollow cylindrical structure referred to as the Guidance and Control Assembly Skirt, GCA skirt. The payload then mounts to the fourth stage via a structural adapter. For the operationally responsive Space 5 (ORS-5) mission, Minotaur IV was outfitted with a second Orion 38 motor, for a total of 5 stages, to allow the payload to be inserted into an equatorial orbit. In addition, the STP-S-26 mission featured a Hydrazine Auxiliary Propulsion System, HAPS, to demonstrate additional orbital maneuvering capability after the payloads were deployed. The HAPS was developed for the Pegasus rocket to fine-tune the payload's orbit since solid motors are not capable of precise orbit adjustments. The Minotaur IV family features a standard 2.3-meter, 92-inch, diameter carbon composite payload fairing. A larger 2.8-meter, 110-inch, diameter composite fairing is also available for larger payloads. To date, no Minotaur rockets have flown with the larger fairing option. The Minotaur IV Plus is a higher performance variant of the Minotaur IV. The first 3 stages are identical to the base model, but the Orion 38 fourth stage is replaced with a Star 48 BV motor. The Star motor features more propellant than the Orion motor, allowing the rocket to carry roughly 200 kilograms, 440 pounds, of extra payload to low Earth orbit, or can allow for payloads to be sent to higher, elliptical orbits. The Star 48 BV burns for 85.2 seconds with an average thrust of 68.63 kilonewtons, 15,430 pounds force, and also features thrust vectoring, which is uncommon for Star 48 motors. The Star 48 motor has also seen use on the Atlas V, Delta IV, and Space Shuttle, alongside over 70 missions on the Delta II. Minotaur IV Plus was further evolved to create the Minotaur V rocket, which adds an extra Star 37 FM stage to the vehicle for improved high-energy performance. This configuration has only flown once as of 2025 and is not scheduled for any further launches. In addition, the more powerful Minotaur 6 and Minotaur 6 Plus concepts were based on the Minotaur 4 Plus, featuring an additional SR-118 motor as the first stage to improve vehicle performance. However, neither Minotaur 6 variant has flown and no flights are scheduled as of 2025. The Minotaur 4 Lite is a suborbital configuration of Minotaur 4. It features the same first 3 stages as the standard variant but lacks a 4th stage. The 4 Lite is intended for suborbital missions, allowing government customers to test new technologies like hypersonic aircraft or missile interception. As of 2025, the Minotaur 4 Lite has only flown twice, both times in support of the HTV-2 program. This variant is similar to the unflown Minotaur 3 rocket, which was also intended to perform suborbital missions. The third Minotaur 4 launch, also known as Space Test Program S-26, STP-S-26, carried 8 payloads to orbit. It was the 29th small launch vehicle mission in STP's 49-year history of flying the United States Department of Defense, DoD, space experiments and was intended to extend previous standard interface development efforts, implementing a number of capabilities aimed at enabling responsive access to space for small experimental satellites and payloads. STP-S-26 launched at 1:25 Coordinated Universal Time on November 20, 2010 from the Pacific Spaceport Complex, Alaska, PSCA, formerly known as the Kodiak Launch Complex, KLC. The launch facility contractor was Alaska Aerospace Corporation, AAC. The payloads were released into a 650 kilometers, 400 miles, orbit before the Hydrazine Auxiliary Propulsion System, HAPS, upper stage was demonstrated by raising its orbital altitude to 1,200 kilometers, 750 miles, and deploying 2 ballast payloads. The primary objective of the STP-S-26 launch was to deploy STP-SAT-2, USA-287, while also demonstrating the ability of the Minotaur IV to carry additional payloads by deploying fast, affordable, science and technology satellite Huntsville 01, or FastSat Huntsville 01, or FastSat HSV 01, USA-220, formation autonomy spacecraft with thrust, RELNAV, attitude and crosslink or FastTrack or orbiting satellite carrying amateur radio 69, Oscar 69, Radio Aurora Explorer or RAX, USA-218, Organism Organic Exposure to Orbital Stresses, ORIOS, and USA-221, also known as FalconSat 5. A Hydrazine Auxiliary Propulsion System, HAPS, upper stage was flown aboard the Minotaur to demonstrate its ability to deploy payloads to multiple orbits. However, only mass simulators were deployed after the HAPS burn. The launch marked the first flight of an STP-SIV, Space Test Program, Standard Interface Vehicle, satellite, the first use of the Multi-Mission Satellite Operations Center Ground System Architecture, SOC GSA, the first flight of the Minotaur IV's Multi-Payload Adapter, MPA, the first use of a HAPS to obtain multiple orbits on a Minotaur IV flight, the first Minotaur launch from Kodiak Launch Complex, KLC, and the first deployment of CubeSats from a Minotaur IV via Polypico Satellite Orbital Deployers, PPODs.